Let's go to page 770, and this is lesson 16-2. The objective of this lesson is to find sums and differences of matrices and products of a scalar and a matrix. Okay, so sum means you adding the matrix. In order to add, you need to have the same dimensions. So let's go to example 1. Okay, so you have 4, 0, 1, 7, negative 2, negative 6, plus 2, negative 3, 0, and negative 5, 2, negative 4. Okay? In order to add, again, because to add you need to have the corresponding numbers, so therefore you have to have exactly the same dimension. If you don't have the same dimension, then you cannot add. Okay? So this will equal to, so again, when you add, you have to add the corresponding numbers. So 4 have to plus a 2 will give you 6. Okay? And this one, 7 plus negative 5 will give you 2. So you only can add the matching numbers, okay? The matching positions. So this one and this one, so when you add, this will give you a negative 3. This one, when you add, will give you 0, right? So you add this, will give you 1. And this one, when you add, will give you negative 10. Okay? And so that's it. Okay? So again, adding is very simple. The next one is when you're doing a subtraction. When you're doing a subtraction, it's same as adding the negative of that. Okay, so over here, well, first let's go over some of the theorem. So over here it says when you have the matrix A and you add 0 matrix, so these are commutable, means you can switch the order and it will equal to this, right? So again, use common sense, right? A plus 0 will equal to A, right? Just think about when you're adding a 0, you will not change anything. So again, A plus 0 will give you A. So think about just one number. It's the same principle. Okay, so difference between that is a matrix have a whole bunch of numbers, but the rules are all the same. Okay, and so over here you got A is equal to 2, negative 1, 3, 0, right? Negative A means you times by negative 1. So 2 times negative 1 give you negative 2. Negative 1 times negative will give you positive 1. 3 times negative will give you negative 3. 0 times negative will still give you 0. Okay? So again, just like a regular number, when you multiply by negative, you just multiply each number. Okay? So over here, so when you have an A plus negative A, just like regular math, right? A plus negative A will equal to 0, right? So same idea. Again, the difference between the regular math and the matrix is that the regular math, you just deal with one number, right? About matrix, you deal with a whole bunch of numbers. That's kind of the difference. Okay, but all the rules are stay the same. Okay, okay. And over here on the next page, page 771. So when you have subtraction, sometimes because there are so many numbers, it's so easy to make a careless mistakes. So when you're doing a subtraction, sometimes it's better to go and add the negative. So it's sometimes better to go and multiply this by negative and you do the addition instead. Okay? And so that's what the example will do. See over here? So you find A minus B. So A minus B, what they did is they multiplied, they distribute the negative inside. Okay? Distribute the negative, and that way you can do the addition. Because addition is much easier to do. Okay? And so after you multiply this by negative and you just go and add, right? So 6 plus negative 4 will give you 2. Negative 2 plus negative 3 will give you negative 5. Because when you have the same sign, you add the numbers together. When you have different signs, you have to subtract the number, right? Okay, so this plus 5 plus negative 5 give you 0. 4 plus 2 give you 6. Okay? And so here are some properties of matrix. Again, everything, all the rules stay the same, right? So closure property, so if A, B, C are the m times n matrix, then when you add, the dimension will stay the same. Okay, so the dimension will not change when you add the matrix. So if you have like 2 by 2, when you add, you're going to end up with 2 by 2. Okay, if you have 3 by 2 plus 3 by 2, you're going to end up with 3 by 2. Okay, so that's what closure property says. Next one is commutative property. You have A plus B equal to B plus A, so you can switch the order. And associative property means you can decide which, if you have 3, you can decide to add these 2 first, or you can add these 2 first. They would be the same. Okay? Next one is adding the zero identity property. That means when you add, you're going to stay the same, right? So So a plus 0 is same as 0 plus a will equal to a. So again, when you add 0, you stay the same. So that's what identity is. Inverse means you're adding the opposite. So a plus the negative a equal to negative a plus a, which equal to 0. Okay? Again, all these are just like regular math, common sense things. Okay? Now the next one is scalar. Scalar is a number, just a number. So let's go over how to multiply. So example 3. So you got A, matrix A is equal to 2, 0, negative 2, 3. And you're looking for 3A and RA. So 3A equal to 3 times 2, 0, negative 2, 3. Okay? So 3A means 3 times the matrix A. And this one, you just go and distribute. So 3 times 2, you have to distribute each number. So this 3 times 2 would be 6. 3 times 0 is 0. 3 times negative 2 would be negative 6. 3 times 3 will give you 9. Okay, and that's it. So it's very easy to multiply. Okay? Now when you have R times A, this will equal to R times A. Okay? And so you just again distribute. So R times 2 is 2R. R times 0 is 0. R times negative 2 is negative 2R. R times 3 is 3R. Okay? And that's it. Okay? So again, the matrix is very simple. Okay, now there are more properties coming up on the next page. Okay. So this has to do with multiply a number. So when you multiply by a scalar, the dimension will not change. Just like this one up here. See, when you have 2 by 2, when you multiply by a scalar, a number, it's still, your answer is still going to be 2 by 2. So again, the dimension will not change. That's what it's saying. Okay, commutative property. When you multiply by a number, you can switch the order and you still come out the same. Okay, associative property. If you multiply by 2 different numbers, again, you can multiply, the order can switch. Okay, you can multiply this first and then multiply by that, or you can multiply P and Q first. Doesn't matter. Okay? And this one is distributive property, just like regular math. You can distribute, right? So when you multiply, you can just distribute. So A times P is AP, A times Q is AQ, right? Or QA. Okay? And so you can distribute forward or backward. Okay? Identity property is for multiplication is when it is 1, okay? Because A times 1 still give you A. Identity means identical, means same, stay the same. So you have to multiply by 1 to stay the same. Whereas for the additive identity, you have to add 0. So when you have something, you add 0, you stay the same. But for multiplication, you have to multiply by 1 to stay the same. And the multiplication of negative, so when you multiply by negative 1, so negative 1 times A give you negative A. Okay? Again, most of this is just common sense, just like regular math, right? And over here, you got 0 times A will give you the 0 matrix, right? 0 times A give you 0, right? Okay. So now you can use this to solve matrix equations. So let's go over example 4. Okay, example 4 is a solve for the matrix X. So you got 2X. Now it's a capital letter, so it's a matrix. It's not just a number, okay? Plus 2 times 1, negative 2, 0, 3 is equal to 8 times 1/2, 0, negative 1, 1/4. Okay, so to solve for this, let's go and multiply this out first, okay? Let's get rid of the things in front. Okay, so actually you can divide it by 2 if you want to. Okay, that's another way to solve, just like a regular equation. Okay, so imagine that if you have 2x plus 2 equal to 8, for example, right? Okay, but so in this case, I actually want to, you have to be careful when you divide. You only can divide by a single number, but the safest thing to do is just not to do it. Okay, especially if you're a beginner. Okay, but if you know what you're doing, the easy way to do is just divide all 3 terms by 2, and it would make things a lot easier. Okay, okay, but in the book, let's just go and follow the book method. So that multiply out. So you got 2x plus. So when you distribute, so it'd be 2 minus 4, 0, 6. equal to, when you multiply, this will give you 4, 0, negative 8, 2. Okay? The next thing is you're going to add the inverse. Okay? You're going to add the opposite. So you have to do the same on both sides. So to get rid of that, I'm going to add the negative of that. So it'll be negative 2, 4, 0, negative 6. Okay? So instead of subtraction, I'm going to add the inverse, which is the same thing. Okay? But a lot of times people have a hard time doing the subtraction. Okay? So I'm going to do the same thing on both sides. Okay? So negative 2, 4, 0, negative 6. Okay? And the reason for that is so that this will cancel out, right? This will become 0, 0, 0, 0, right? So you're going to get 2x is equal to, and now you can go and add. Now remember, you have to add only the corresponding numbers, right? So you only can use this number, add this number, so it gives you 2. This you add, you get 4. This one you add, you get negative 8. This one you add, you get negative 4. Okay? Now the next thing is, you want to avoid doing the division in the matrix. So in this case, what you want to do, you want to multiply by 1/2. So now one thing about the matrix is that keep a good habit of, if you multiply by 1/2 in the front, you want to put in the front. Okay? So keep a habit of doing that, and it will save you a lot of trouble later on. So that 1/2 and 2 will cancel out. So x will equal to, and you distribute. So 1/2 times 2 is 1. 1/2 times 4 is 2. 1/2 times negative 8 will give you negative 4. 1/2 times negative 4 will give you negative 2. Okay? And so that's it for your answer. So the matrix x equal to 1, 2, negative 4, negative 2.